Hello and welcome to another Bevy video. So yesterday, Bevy 0.1, no, Bevy 0.10 came out, and I recorded this video earlier today, and it took an hour and a half, and I didn't have my microphone on. So if I end up sort of glazing over something, it's probably because I think that I've explained it, and then lost the footage, so it didn't actually make it into this edit. But Bevy 0.10 is a huge update, so feel free to just sort of jump around the video to the topics that actually interest you, because I do feel like an hour and a half long video going into sort of my thoughts on a lot of the topics is very, very dense, and you will have sort of a long time if you just sort of watch stuff to finish. But to sort of show how much is the short list fills my entire screen. So there are a lot of things that this update brings. So we'll jump straight into it because I'm saying long video, it's going to be dragged out. So the first thing is the scheduler version 3. So this is a stageless scheduler, and basically is that Bevy's original scheduler was broken down into stages, and after each stage it would apply its commands. So this meant that you had fixed breakpoints where you couldn't interact across these boundaries with systems, since they were actually separate schedulers that ran after each sort of breakpoint. And this could cause crashes if you tried to, say, make a system run after a system that was in a stage before it. Because even though logically it makes sense, the stage will run and then the other system will run in a stage after. So it is after. It wouldn't know that the other system existed because it's in a different stage and therefore in a different scheduler. So what Bevy's done is they've basically made it into one really big scheduler with a whole bunch of sort of systems that all talk to each other, and architecture required to break the scheduler back down into those sub sort of sections so that previous Bevy code and reasoning still works, but it expands upon the ability for systems to sort of go, hey, that system, I'm after that system, and whatnot. So the this is all done as just one singular unified scheduler. Obviously, there are actually other schedulers, such as the startup scheduler, but we'll get to that when we get to that point. So the scheduler is sort of broken down into all these big chunks, and these are, again, like sets that you'll see in a minute. So what this does is, first off, they added some new functionality. So you can add systems like you normally did, and this will add them to the default scheduler. You can then, now also add groups of systems, similar to how you can tuple plugins. You can tuple components, so you can add multiple systems at once. So then they're showing the example of how you could chain systems together, saying walk before jump, then jump, and then collide after jump. And you can also do this as adding systems. But the more important thing, and the reason why they had to add systems as opposed to just combining systems, is you can now call .chain on this tuple, and this will cause them to automatically get labeled in such a way that they will execute in the specified order. So you end up with the same functionality as this, but in a much more concise bit of code. They will execute in this particular order. The other thing is you can also chain together, or you can add labels to the first system in this chain to make it run after inputs, which will then retroactively apply that to all the others, since they can't run until walk. So you end up with a much more intuitable architecture in this map sort of thing, of one arrow pointing, inputs will point to the walk, and then walk. So you end up with you can clearly see how the systems have to execute in the specific order that they do, which is really quite obvious in this picture here. In that, say this system has to run here, and then because these two have to wait for this one to finish, you end up with these can run in parallel, but these can't. So it's much more, when you generate these render graphs, easy to tell where your bottlenecks are of certain systems that have to run on their own, because of the this system feeds around past these systems into this system, but check visibility can't run until after the frustums have been updated. So you can see that where the bottlenecks can occur. All this can run in parallel. This has to wait for this. Anyway, back to our thing. So they're basically just like increased boilerplate, but then stripped it back by adding helper functions. And so that's a lot of fun. So the other thing with doing this, for anyone that's aware of how Bevy's old scheduler now worked, is that you could make system sets, and system sets were like bunches of systems that would run at the same time. The big issue that they're fixing now with system sets is if you added a system to a system set, it existed exclusively in that system set. So you would have to add like 2 copies of the same system if you wanted them in 2 separate system sets. Now, because it's all in one scheduler, you can just put the same, like actual same system, not just another instance of the system, into two or more sets, sort of thing, to result in like having logic that's like, if physics is running, I want this system to run, or if a different system that may upgrade positions is running, I also want this system to run. So it can be in both sets without just needing 2 copies of the same system that may run twice if both of these sets are enabled. So it allows for sets to overlap and have interactions, or disable and enable certain things depending on their functionality. In order to put things in sets, instead of having to create a system set, insert things into it, add the run criteria to that set and all that, you can just inset the actual system when you add it, similar to the before and after. And you can also, say chain those into the set as well. So it all works together. And here's they can put multiple sets, and also the .configurable set is if you want to change how a specific set works. So in this example, physics movement happens before collision detection. It means everything in the movement set will happen before the collision detection. And so this can do interesting things, because obviously you wouldn't want those 2 sets overlapping. And I believe Bevy will have error detection that will report that you've got a system that's in something that, like if it's in both sets, those 2 sets can't be separated. So this would catch those kinds of errors where you've got something in both movement and collision. So yeah, and also they're saying that you can nest a set entirely inside another set. So like lots of architectural structure that you can build out on top of what Bevy already provides. So directly scheduling exclusive systems is now a functionality. So in 0.9, they added the groundworks for this, which was that they removed the need to specify that it was an exclusive system. Anything before 0.9, I believe, at least, you needed to specifically say that a system was an exclusive system. But in 0.9, they removed that and just treat exclusive systems exactly the same as normal systems. Except I believe they ran at the end of a stage. So all your parallel stuff would run, then your exclusive stuff would run. The issue with this is that you couldn't add labels, so you couldn't order anything because your exclusive systems were just at the end. Now, because it's all one big schedule, they had to add this functionality, so why not give it to the user, of allowing you to specify where in the schedule these exclusive systems run. And this is partly how they generate the staging effect without stages, is that the commands are applied as a few systems that have specified points where they run. So this allows you to now order exclusive systems. So if you have a system that runs and does some code that runs in parallel with others, and then you want to apply the commands and then run a different system, you can do this with this functionality. So it's saying like, so you run system A, you apply the buffer, then you run system B, and you can chain that all together and you get the same functionality as putting them across a stage line without needing to actually have a stage line, which also means that you can have a lot of plugins and stuff have like their own staging set without needing to specifically know how the stages are. Whereas with the way that Bevy was set up in 0.9, if you added your own stages, it would just slow everything down, even if the user of your plugin wasn't using it, because Bevy would run a scheduler for each stage. Whereas now if there's nothing there, it just runs the system and continues. It doesn't have to do all that overhead. So they talk about managing complex control flow with new scheduler that you can build, because you can build your own custom schedulers and insert them as well, or have custom running logic. So the idea with this is that basically the scheduler that we're talking about, the single unified scheduler for Bevy, is only for the update frame loop. There's actually multiple schedulers that Bevy creates and then runs, but they run at different stages. So there's like the pre-start scheduler and the update scheduler, and there's technically a scheduler that wraps those two. But what they're saying is, using this scheduler architecture, you can build, say, like a physics engine as its own scheduler, and people using your crate can register their own systems into your schedule, and they will run on your schedule. And so, for example, with a physics world, you may have that run 5 times or 10 times as your like micro steps per frame, which results in, you can write systems that are supposed to run fast but multiple times per frame, and have them run with their own, complex logic, as they call it here, about when that scheduler should run. Or you could say have code that runs at very specific times, like only do your mesh generation code every 10 or 15 frames because it's very slow. So you only ever run that code when you're like, all right, it's tight. Like, an example I would give is the Dinosaur Tycoon game. If anyone's watched my first video on that, in that, this scheduler system would be great for my mesh generation, in that I could run it to do all the complex setting up the mesh generation, then pass that into a background thread to generate the mesh with all the data it's been given. And then like 15 frames later, run the schedule again to come collect that, as opposed to needing to do those checks every single frame. I can only check to see if the meshes are done every 15 frames because I know that they may take a long time to generate. So then talking about how Bevy uses this pattern is it has a scheduler for startup, which means that at startup, it runs the schedule that you've told all the things these startups, they run, and then that scheduler can be thrown out. It's never used again. Then there's the fixed time step scheduler, which instead of running on every as fast as it can, it has a fixed time step. It'll only run at so many frames. The entering and exiting of stages, which is with old Bevy, they had system sets that you would create with a run criteria that would need to be checked every single frame, which meant that if you had lots of stages that were changing all the time and lots of related to stage things, you would end up spending a lot of CPU time. Obviously, minuscule compared to the actual execution time of code, I'm sure. But you would have to check each of them every frame to see if they need to run. Now, you simply run the scheduler for the entering or exiting of that stage. And since all your logic keeps getting added to the same scheduler, not a system set that runs with run criteria, there's no overhead whatsoever to using these entering and exiting stages in multiple places. Like, they all automatically get condensed into one. So they also have the rendering scheduler, which runs now parallel to your code, which means that all the rendering stuff can be done in its own logic without needing to have to wait for your game logic to run, because the scheduler can be run in parallel, asynchronously, as they say. And then there's the controlling outer loop, which I mentioned, that basically just is a scheduler that does the startup schedule and then runs the fixed time step schedule and deals with the entering and exiting schedule every frame. So this is sort of your frame control, and then it runs these other schedules at the appropriate timing. So Bevy also has stripped down its run criteria. So in old Bevy, there was a enum that was returned, which was like yes, run, and then ask again, no, don't run, like all these different variants that you could have. And they've changed that into just a Boolean. Like, it literally runs a function, like a system, that returns a Boolean. And then based on that, you can say whether a system runs or not. So, for example, in this particular case, if the player's alive and has a score of over 9,000, run the win game condition. So that's our check, and then we add a system, win game, and then run criteria of game win. And so basically we can make really small systems that will check to see if bigger systems need to run. There's expanded functionality on top of this, like for example the not, which I guess just inverts it, and then the and then or else versions. So you could say, move player, run if the player is alive, or else if they're a zombie. So you can do 2 checks, as opposed to sort of the old system of doing it. You would have needed to have a system that checks is alive, a system that does is zombie, and a system that does is alive or is zombie. They would need to be independent systems and duplicate code. So this particular one now allows you to chain them together to reduce duplicate code. And it just talks about run conditions. And so like here's the should run yes and check again, which cause loops was confusing. They do say that this functionality can be recreated, but for 99% of cases, it's simplified to just a Boolean. So they've also simplified states because, like I'm saying, they've removed system sets, they've yanked all that out and made states their own schedulers. So now to add a state, instead of having to provide the original default state, it just now states need to have a default. Originally, in 0.9, you had to provide the entering state, and they've also changed how states are updated. So originally, in 0.9, Bevy had states as a stack, so you would get the state object, you could insert the next one or pop the old one, which was somewhat useful, but most people weren't accessing this functionality, and it was just adding complexity. I know from my experiences with it, I would just toss out the errors it returned, because most of the time the error was you set the state to what it already was. So Bevy's stripped this all the way back, and they've now said if you want to change the state, you set the next state resource, which is its own independent resource. Then Bevy will schedule the next, or the on exit and on enter appropriate run those schedules. So here's that example. So they'll run these in those schedules. And then also there's the on update set, which is the systems that should run when that state is active. And basically they've just simplified it way down. So instead of creating lots of system sets, it plays into the new ECS system of allowing you to create very complex structure. And they point out that if you wanted the old functionality, it's not particularly complicated to build that on top of the current functionality that they've implemented. So then they've also got base sets. And base sets are about re-obtaining that sort of user-friendliness intuitive of stages. So they've ripped stages out and then sort of gone like, here's the same concept, but implemented in a better way that, more parallelizable, more. So basically, every system needs to be in a base set. Very much similar to how every system needed to be in a stage. And by default, they go into the update stage. And what this allows you to do is specify that this system has to run before any code that you would consider to be update code. So you can put it in the pre-update base set. This acts like putting it in the pre-update stage. And the idea behind this is that it allows for plugins to say hey, we do all our update user inputs in pre-update. So if you want your user inputs to be accurate, they need to go in update. To read our components, Leafwing's input manager. You have to have your code running in update, because otherwise there's no guarantee that Leafwing will have updated the player state. And this can result in lag frames or duplicate frames and all sorts of issues with systems running in arbitrary orders. So base sets are just the stages from old Bevy. And basically the components will be flushed between each transition between core stages. And like in previous Bevy, you can add your own stages base sets by adding the base set attribute. And then you can also apply the functionality before and after other stages. Or base sets, it's going to take a bit to not keep saying that. And so you can configure the set to run before or after specific points, hence early, late, and then you can export your base sets out of your plugin for other people to use. Bevy does give a little example of a theoretical user of Bevy, and they're saying that they may implement this stuff and build all their labels and everything about getting it working properly, And then Bevy will update, or a third-party plugin will update and break everything because they moved one thing internally. So base sets are about allowing you to sort of broadly specify this stuff will happen here, this stuff will happen there, and then the user can go, oh, I need it to happen after that, so I'll put it in the after section, or I need it to happen before that, so I'll put it before, as opposed to, you know, not needing to know specifically exactly what system they run before and after. They've also improved arbitrary system detection, which is the idea that if you have a system that reads a trait, like a particular component, and a system that writes a particular component, the order that those execute is important, so it introduces ambiguity. And so Bevy will now report better about more situations where this particular, like, you know, you may have frame lags or something, and it'll hopefully inform you more. I think in 0.9, Bevy would only tell you this if you had two systems with mutable access to the same components or the same resource order. It would say, hey, this resource may have changed, like, depending on the order of these plugins. So it would request that you label which one gets to go first. You can also change schedulers to be single thread execution. This doesn't have much impact if you're trying to use the power and speed of Rust. But the big thing that I could see this being useful for is if you're building a game similar to RimWorld and would like to have sort of like two different sets of systems that run, and you don't want one to consume the other, you could say have a physics engine, your renderer, and say like your pathfinding AI all running on executors that run on single threads as opposed to multi-threading. And this would mean that if your physics engine is running particularly slow, your physics steps may get bigger and take, you know, longer to run, but your pathfinding won't slow down, your rendering won't slow down. So you just put them in individual things. Whereas if you didn't do it this way and didn't have single executors, your physics engine would, you know, as it's running, consume all of the threads or all the cores so that these other executors can't run. So it's just sort of a way of like allowing you to specify that, like, I want this thing to never use more than one core, and allowing it to, you know, not run parallel. Just more control for the user, I guess. So cascading shadow maps. Cascading shadow maps is the idea that based on the distance from the camera, you'll use a different shadow map. So in the 0.9 version, Bevy had sort of one big shadow map that it sort of picked and went, yep, this is my shadow map. And depending on where you were in the world and other conditions, could change the quality of your shadows that you got. So what Bevy's doing instead is using the camera and splitting it up, like the camera's frustum, which is the view that the camera can see, and putting multiple shadow maps in there at different resolutions, decreasing as you got further away. Or another way of looking at it is the same resolution, but covering a bigger area as you get further away. This means that no matter where you are in the world, your shadows should be the same because they follow the camera around, and anything close has good quality shadows. Whereas things far away, like way up here, you can see like they're just spots that they're doing, like single pixel sort of spots. I'll wait for them to come around again, and so like they're much lower resolution, but this doesn't matter because they're much further away. And so this just sort of results in more consistency about how and where to place things. I don't remember, but I believe you can configure this like per scene sort of thing to allow, you know, shadows to be more high resolution on particular maps than other things. They've also added environment map lighting. This is something that I'm not entirely versed on, but I believe it's the idea that you sort of your skybox can cast shadows or like project light. So in the current 0.9's PBR, it would result in like everything sort of having this lighting. Whereas with this, you can now sort of get reflections based on the sky map because it acts like it's projecting light, so therefore it will reflect. And it also means that you sort of light the underside of things a little bit, resulting in like more naturally lit scenes. Okay, they've added depth and a normal pre-pass. So this is the idea that in shaders, you usually need the depth and the normal calculations for a lot of like effects, like this portal effect here, where you can see the force field is hitting the ground and it knows where the ground is. In order to do this, you tend to do depth calculations where the camera calculates how far away any specific triangle, like so that pixel, when does it hit something, so calculating its distance. And the pre-pass is just the idea that you go through and calculate all the depths and all the normals and then pass that information to the shader. This results in, if you have multiple shaders that run on each frame, they don't need to calculate the depth each. They have one shared buffer to the depth that they can do. It also allows for certain effects to do certain things, like certain culling to happen, because it already knows that what it's about to render will be blocked, because it can look at the depth map and go, I'm about to render something behind that, so don't bother rendering. This can improve performance, but also it can reduce performance because you're already running, like you're running an additional pass, and if you're not using that depth and normal data, you're doing a redundant pass. It's also a slight extra computation. So if you only have one shader that is using the depth normals, it could calculate it itself and it wouldn't make a difference. So the extra overhead of doing an extra pass would slow things down. But in a lot of cases, especially when Bevy implements this stuff into its own shaders, this will be a nice performance improvement. This is an example of showing like how you can do edge detection with this one's doing normals, the green, and the blue is using depth for edge detection. And then this is just like what your depth map and your normals map would look like. And the depth map, the brighter the color, the closer it is to the camera. So obviously it further away, darker. And with the normal map, the color of the pixel, I believe like a red, blue, green channel, indicate the normal vector of the normal. So hence these ones pointing down are purple, whereas these ones pointing sort of back into the side. But this is not really important because unless you're making shaders, in which case you may find this incredibly helpful. But for a lot of people, this is something that will help in the background for a lot of the cool plugins that you may implement. Yeah, another thing is that the shadow map now uses pre-passed shaders. What this means is that in 0.9, Bevy's shadow map just used the mesh. It didn't use the material, which meant that there was no way to encode transparency. So these leaves down here would have just been squares because the best geometry to render a leaf would just be either a square or a rectangle or triangle with the leaf texture on it and with transparency. But since it never got the material, it would never be able to put that transparency in. But now it also gets past the material, so it can calculate transparency. So things like your trees will cast actual leaves instead of blocking the ground entirely. Bevy has also added smooth skeleton animation transitions. And personally watching this video, I can't really notice, but that's probably the goal with transitions, is that you don't have that stutter of like this animation ended, this animation started, it jumps. It will actually blend from one to the next. So it's a great functionality if you're using 3D animations. I believe in the next time section, like what's in the next update, they talk about, I think, allowing to have more dynamic stuff of like having like the top half and the bottom half separate. But there's some example code, but again, for a lot of people, it's like if you know what you're doing, you can specify how long to take to transition and all that kind of stuff. So they've improved Android support. The idea, the way this works is Android, when you open an app, will send a resume command, and Bevy takes this as a, oh, okay, I will start the app as if it's the first time I've ever run it. And then when you like tab to another application in Android, it'll send a suspend event. And Bevy takes this as, oh, okay, kill the application and close it entirely, as if it never, as if you closed it on a computer. Then obviously when you return to it will resume again. So you would have to write some kind of code in order to make sure that persistence, like the app starting again each time. But this will be fixed in the future, and eventually Bevy will hopefully implement proper suspending. But for now, what they've done is they've brought Android up to a level where they now only have to provide a mobile example as opposed to an Android and an iOS. So they have the same example running on Android and an iPhone. So that's pretty cool for people that want to do mobile development. It's much simpler now, even though you still have some caveats with Android. They've revamped Bloom. So basically they've just tweaked how it works. So picture 1 here is how bloom worked in 0.9, like what it would look like. This is what it would look like when you used a HDR and then used your tone map to correct it. So much more blown out. But so this is 0.9 of these two. And then these 4 are the new implementation. So this is the default bloom. And then I think that's tone mapped. This is we're tweaking bloom settings of these two. And then this is just an example that you can run through if you want to see, like, I'm assuming scales of bloom and changing over time. I'm not quite sure. I haven't run the example. They also added fog as something that's enabled per camera. So you can now have different fogs. And they have, you can set like the color of the fog and how quickly it falls off and starts. There's also different parameters for how quickly the density changes in terms of the fog. So this will be good for people that want nice atmosphere and render distance to be implemented without needing to have fall off and whatnot. They also have the like an atmospheric fog that you can use as well, which uses directional lights to influence this. So it all looks really nice. And I think there's also like a rendering improvement in the sense that you can use from visibility, like a fall off distance, that an object won't render if it's like less than 5% visible through the fog. So I think that's what it is. Or like it makes the fog dense enough that you won't be able to see more than 15 units. But the idea is that you can not render certain things because the fog will hide them, whether you do that with code or shaders. So they also added new blend modes for standard materials, and they are the add, multiply, and pre-calculated multiply. And the way this works is that the add will simply combine the values of the color, intuitive what add does. Multiply will multiply them, and usually you will end up with a darker color, because unless you're multiplying, say, by like white, red, green, blue, the number that you're going to get will be closer to 0, because multiplying any numbers less than 1 will result in a number smaller. And then there's the pre-multiply, which doesn't combine the alpha channels. So it assumes that the alpha channel has already been corrected, and this will result in like more better transitions between like the edges than the blend does. They added more tone maps. So up here in the bloom, they talk about using the tone map that Bevy had in 0.9. Or at least I think that's what I was talking about. So now they have the option of multiple tone maps. From those that don't know, the tone map, if I'm correct here, is about taking your high dynamic range scenes, so you're like beyond human comprehension level of detail, and compressing it down into the scene that actually gets rendered in colors that we can, intuit about. And the tone map is sort of like the formula that you use to convert. So on this, you've got no tone map. So you blue with your light, so it gets condensed, and it sort of, as you lose that contrast, you get this purplish color, because the blue stays at maximum and the other color sort of gets squished into it, so it sort of lightens the color. And you can obviously use other formulas. This one obviously compressing it significantly more closer to white. Down here, there's this one which is like the lighter colors get compressed, but the darker colors keep their true state. And then this one, even the lighter stuff gets compressed. So it's you pick the appropriate tone map for the type of effect that you're going for. And I believe it's just about converting your high dynamic range image into your normal dynamic range. So Bevy added a whole bunch of them. The color grading control allows you to, very similarly like to the tone map control and things, change the exposure and the gamma of your camera along with the tone map saturation and post-tone map saturation. So you can sort of tweak your color grade even more. So in this example, this is 0.5 exposure, whereas this one is a 2.25 exposure. So it has like 4 times as much light getting into the camera, which means everything's much more washed out and bright than this one. So for people that like rendering and are really into making really stunning games, this is going to be amazing. But for me personally, I'm not really versed on rendering, so it's just a lot of cool lights to me. But it'll be great for people that know what it's for. The other thing is that the next thing is that they've parallelized the rendering pipeline. Because of the new scheduler system, they're able to run the rendering in this exactly the same time as the app's main logic, which results in, I think they said, a 10 to 30% speed up, because in 0.9, it would have to run all the game logic and then render the scene, which could result in frame times taking significantly longer. Now, obviously, if your game is running full tilt and saturating every core, this isn't going to make much of a difference. But if you've got sort of any time between your game logic and your rendering, they no longer need to be next to each other. They can be on top of each other, speeding up performance immensely. Windows are entities now, which is another one of those, for most people, not going to make that much of an impact. The big impact this does is makes it significantly easier to edit and manipulate windows and change properties about them and factors. So if you wanted to, say, do like the software ink approach of having like each window that you open has like a little window you can move around, like each tab and all that, this makes that significantly easier because you don't have to fuss around in resources. You instead have like each one is a component. It also means that you can use queries to detect changes in windows and stuff like that, which will make like user interactivity of like being able to resize windows and have other systems respond to that significantly easier to implement. With this came also a lot of render optimizations, which isn't specifically to do with the Windows being systems. Give me 2 seconds. Ugh, sorry, the dog wanted to go out and I don't need him whining in the background. So with the render optimizations, they've gone through and found things like the fact that even when disabled, logging would slow down your rendering time by 20 to 50%, which is a pretty huge impact on rendering. Then there's other things like we shrank the code data structure involved in the stage, reducing memory, and yeah, so they did lots of optimizations which all sort of sped things up incrementally. Down here they talk about they've also optimized the size of things, like making visibility smaller by using a bit flag instead of multiple booleans, and then they also talk about optimizing very specific cases, such as like extracting bones from skin meshes is now significantly faster. So a lot of that stuff is like either you won't need it at all because Bevy is fast enough, you'll hugely appreciate it because your code was needing these specific things, but a lot of this is you don't need to touch it, Bevy's just significantly faster. They've also parallelized transform propagation and animation kinematics. This is that Bevy's hierarchy used... apparently I'm going to have lots of interruptions at the moment. So the parallelized transform propagation and animation kinematics is another one of those points where it seems that this update, Bevy seems to be quite focused on optimizing games with lots of entities. So one of the issues with Bevy is because it needs to propagate the components through in like a linear fashion, because it can't do it mutably in parallel. The biggest thing that suffers from this is transforms, because every component has a transform, or almost every entity has a transform. And so it takes a long time to propagate this through in a single thread. And in a lot of cases, this doesn't end up being a problem because you'll have other game logic that will run doing its thing. But the limitation is a lot of things also can't run until after this finishes. So okay, it appears my quiet time to record is probably come to an end, but I'm going to hopefully get this video finished. So, as I was saying, the performance penalty of having to propagate the transforms isn't usually noticeable if you have lots of other things using up their time, because it's not likely to eat into your 13 milliseconds or 16 milliseconds that you have at 60 FPS to do a frame. But the fact that other things have to wait for this to finish before they can do their work, such as the extracting of meshes and stuff like that, the faster this system can run, the faster the absolute maximum frame rate of your game becomes. And also anything that relies on transforms becomes faster. So what Bevy has done is parallelize this system in correctly structured hierarchies. And when it refers to a correctly structured hierarchy, I suspect it's referring to the fact that each entity can only have one parent. This means that if you grab all the root entities that don't have any parents, you know that you can go down their entity, like their child list, and update them in parallel without any risk of mutable conflict and all your race conditions and parallel problems that Rust tries to avoid. So you can avoid Rust's safety checks because you are sure, if the hierarchy is built correctly, that these entities cannot interfere with each other. So I believe this is how Bevy has sped this up, basically just by parallelizing the whole system. And I would guess it goes roots down, but it may have other systems, because in theory you could go like 3 layers, then create more threads and go more. Depends on how your hierarchy is structured to what would be the most efficient. But Bevy's example that they use for hierarchy testing, the many foxes example, goes from 100 FPS to 400 plus FPS. So that's about a 5-time increase to speed. And most of this is just because the bottleneck is the transferring and updating of all of the transforms, because these can't run in parallel since their rendering UI, physics, and animations all rely on the propagation of transforms first. There's more ECS optimizations, so they just made things like query for each and that faster, and just they changed entities to entity ref and get ref, which all have internal mutability, and just a lot of cache friendliness so that it runs even faster. So a lot of things have just been made faster in this update as well. System parameters improvements is that Bevy has now made system parameters derivable, and this makes it more flexible, more encapsulated, since it now protects private fields, and removes the 16 field limit. So Bevy currently has a limit of 16 things can be inside a tuple. If you make a tuple like a query for components and you wrap it in a tuple, you can put 16 things in that tuple and then it breaks. So then you need to wrap it in another tuple, and then you can have 16 tuples of 16 items, and then you have to wrap it in another one. And this continues nested forever. But this is an artificial limitation in that they've written macros that will automatically implement it up to 16. So if you make your own, such as, say, a physics system parameter, and that query is for every entity that has the requirements for your physics system, you can make this a system parameter as opposed to a tuple that you can pass to your query. And they've just made this easier to use and probably faster by all the speed ups up here. So deferred world mutation is very much like commands, but you can now create buffers of commands that will be applied once sort of a system ends, which allows for multiple systems to write events without holding on to mutable references to things that they don't need to be mutable references to. So this very much acts like commands that I showed off in my Bevy Basics commands video, where you can write a system that may take a really long time to run, that at the very end of that system inserts its thing into a resource. And so you wouldn't be able to run this in parallel if you had the mutable reference to that resource. But what you can do is use the deferred in this example, which will run when it gets to the end. So once this system returns, the deferred will be executed as a buffer, allowing you to grab mutable access just long enough to insert and then continue. So this allows for systems to run in parallel and only do their mutations right at the end, which is significantly useful for a lot of cases. Note that this feature should be used with care because it can cause a lot of potentially worsen problems if you don't use it properly. And it says like a lot of these speed ups, they say benchmark it for your specific use case. Bevy also added the ref-t queries. So ref-t works exactly the same as mute-t. So mute-t allows for change detection because whenever it mutates, whenever you mutate the value, it will update its internal change detection. The ref-t is exactly the same, but ref-t is an immutable version. It just allows for change detection. This means that Bevy has removed its change tracker T type, so you no longer use that to track changes. But what this allows you to do is not necessarily query for when it's changed, but you can like print the last time it was changed, things like that, or say do a change after so many ticks of it having not changed. This allows for all the things you could do mutably, but with an immutable version. So they've just sort of expanded it into the immutable because people obviously were asking for it. Next is cubic curves. I'm not entirely sure what cubic curves refer to. I know what Bezier curves and that are, and it's sort of like they're functions to describe curves through space, is what they are. And so Bevy provides 4 by default, and there's some examples of where you can use them if you want to read. But it's basically like tweening, either animations, smooth camera acceleration, and it's all to do with like you can predict where something is if you have its position and acceleration, and so these are just curves for calculating fixed time positions, and it just says that they're very fast. Obviously, with easing, it's an iterative process, so it can take much longer. But these are not like iterative implementations like physics would be. So calculating the position of something with its velocity and time as a physics would require you to step through the physics each time. These are sort of like not calculated physics, but instead like you can just skip forward in time, and so it's all over one in terms of calculations because it doesn't iterate at all, it just predicts. Bevy has added Access Kit integration, which Access Kit, from what I understand of reading this section, is a crate that allows for you to use like your e-reader and like disability stuff, like your visually impaired equipment on your application in Rust. So like it exports that information. Bevy has now integrated this so that UI elements with text on them will automatically expose this to the external applications that these things use, and allow you to do things like control games with keyboard and stuff like that. And this is now all on by default. Hopefully Bevy implements this in a way that makes it easier for people to have accessibility than to go in and not have accessibility. So, for example, the fact that it automatically exports all text elements to the screen reader means that you don't have to go in there and specially say, oh, I want this bit of text to be like UI elements can automatically have that extracted and presented. So I'm not entirely sure how it works because this is not something that I've ever used, but hopefully Bevy implements it in such a way that it comes out of the box by default. They do say somewhere in here that they're like the only engine that seems to have this by default out of the box, which I somewhat believe because from my experience with Unity, there is no like, here's your accessibility stuff. Like if you want to have that, you have to go find someone else's implementation and include it in Unity. Bevy has it out of the box on by default. Bevy's also added spatial audio. So apparently the crate that Bevy uses underneath, the underlying library, radio has spatial audio functionality, and Bevy 0.10 expands this to allow for basic spatial audio, which would be like audio playing through the left speaker or the right speaker, depending on where you are in proportion, as opposed to just playing audio to you. Like it's dependent on how you position in the world. So it apparently currently doesn't have emitters and listeners, which are like different ways of like interacting with sound without like necessarily the human, like the person hearing it. But I think that when they say first class, they mean like Bevy provided ones. Instead, they're having to convert, but I'm not entirely sure about that terminology. But they also talk about like a bug, if you're interested in audio stuff, about like depending on if you're in release or in dev mode, it would swap which ear, like the left and right. But that's all been fixed upstream, and just, they just give some reference to some reading if you're interested. They've also changed how their custom audio sources work. So in previous versions of Bevy, you could implement custom audio sources. So this is like, you could have like a stream coming from a website of like audio that your game can tap into and play as if it was a music file, that kind of thing. Like, so you might have ambience or something. But to set this all up, you had to include like a lot of boilerplate. And Bevy's stripped that down to literally just like one line. So we're going to get back into some more shader stuff. So they allow you to defer values now with shaders, so shader defer or def. This is like a static value for shaders. I think they call it a constant, but it's more of a like, you can pass in values from your application that go into the shaders. So this allows developers to pass constant values into their shader. So you can do things like maximum number of lights and change the effect of the shader based on a constant provided by the user. And there's some more functionality like else if def chains in shaders, just functionality that makes shaders more usable, like more customizable without you needing to edit the shader as the end user. Instead, they can let more capable people, like, or people that are more passionate about it, I don't know, however you want to phrase it and not get offended. I don't know why I took that way. That's weird. It lets you customize someone else's code, and they can like leave points where it's like, oh, you can set these values, or you can define something, and if you don't define it, I'll use my default. They also split up the global and view into their own imports, so that you don't have to import all of PBR in order to get access to them or declare them yourself. Instead, you can now import global and import view. So basically saying this has been turned into this. So it's just about breaking up the shader code into more usable functionality to reduce duplication and protect against refactoring errors. Okay, so adaptive batching for parallel query iteration. For people that want their game to run fast and want to maximize the use of multiple cores, you need to parallel iterate. So if you do a query for a bunch of things and then obviously just iterate through it, you're only using a single thread. Obviously, all your other systems might run on other threads, but if this is your bottleneck thread, you'd use a parallel iterator, which will then split it into tasks and run them on separate threads. In 0.9, you used to have to specify a batch size, and they say in here about how people would fine-tune this batch size to their machine, which is obviously not the best choice for every machine, or they would just set a fixed value and forget it. So what Bevy 10 does is it uses a custom heuristic, which is just sort of a system to sort of determine the best between performance and speed and whatnot, while remaining small cost itself. So it determines from a few factors the best number of the best batch size. It uses this to automatically generate these. So this means that now you turn an iterator into a parallel iterator and just pass the function. You don't need to specify the batch size anymore. Bevy will pick the batch size that it thinks is best. Though if for some reason like the perfect batch size and you know better than you think Bevy's automatic heuristic will do, you can obviously provide your own fixed batch size. I also suspect that this would be a perfect opportunity for Bevy to add, say, like a variable batch size of like you can specify your own heuristic function. But I haven't actually looked to see if they have that functionality. Though they do see batch strategy is like its whole thing. They've added unsafe world cell and unsafe entity cell. These are internal mutable structs that allow them to build the larger data structures on top of the world, and allows for Bevy internally to create much faster code using unsafe blocks, because they have certain rules that they know that they can set, such as you can't access the same entity multiple times, that kind of thing. So if you were, for example, building an iterator over an entity, or over a collection of entities, you know that each entity will only turn up once. Entities can't share components. They can have the same component, but they can't share the same instance of a component. This allows you to then run this in parallel with mutable access to both, since you happen to know that you won't be accessing the same memory twice. So, unsafe implementations of these for people that want or need that. They've added the what shape is it? Cylinder, so this one here, to the primitives list. They've also made it so you can subdivide planes. These are just general geometric shapes if you're messing with meshes. That can be useful. Camera output modes. So this is, again, something a little bit beyond my comprehension, but it appears that the anti-aliasing didn't play nice with how multiple cameras would output to the buffer. And Bevy uses double buffering, if I remember correctly. In 0.9 they added that. That means that the camera will render into one buffer and then pass that to the shader, which will render into that other buffer, and then pass that rendered buffer. So you would only need 2 copies of a frame, and you would, as each pass went, render into the back and forth. But this causes issues with the anti-aliasing, because I think it would sample weirdly or something. So Bevy now lets you sort of specify and modify how your cameras write to the buffers. And they've also got WSAA, which is multi-sample anti-aliasing, right back, and it's set to true by default, but you can disable it. And basically what they're saying is most people won't disable it, but if you want or need to, it's there. So it's just sort of more configurability. A good improvement that I've found, like when I was updating my dinosaur game, is configurable visibility is no longer a Boolean, but now an enum, with the values hidden, visible, and inherited. In the old version, Bevy had just a struct that contained one field, is visible, and it was a Boolean. The issue with this was it meant that it was not possible to have the parent hidden and an entity visible. Now you can, because if you specify visible, it will be visible even if its parent's hidden. And inherited is the functionality that we originally had, where if your parent is hidden, you are hidden. And then obviously hidden will then propagate through the children, as was the false version of is visible. On shaders, you can now bind group buffers, storage buffers. So I think this would be good for compute shaders and stuff like that. Also for like instancing shaders and grass shaders and stuff. You can now pass in like a buffer to the shader as well. Again, this is beyond my scope. I'm not very good at shaders at all. Stay tuned for my dinosaur tycoon game video where I go in a lot more detail. So you can now drive extract components. So for those of you who don't know, Bevy at the moment keeps 2 copies of the world. One that's the world, and is where you run all your game logic and where you as the programmer will mostly be interacting with the world. And then has a second copy of the world that is called the render world. And this world is where you put all the meshes and stuff, you make a copy of them so that the render pipeline can interact with and grab them without messing with the main world, and also just cuts down on size and stuff. But it's primarily about allowing the two to run in parallel, since once it's in the render world, the main logic won't touch it, but your main logic can keep running, and then the next frame you'll update the render world. So in order to allow this, you need to specify what components actually get pulled across from your logical world into your render world, because you want to keep the render world as small as possible. This is where the extract component comes from. These are components that are taken from one world, or they're copied from one world into the other. So this used to have to be manually implemented, and now they've got an automatic implementation. So it just literally clones it from one world into the other. The next implementation here is you can also specify filters to be applied to the query. So for example, with fuel will mean that only cars with fuel attached will be put to the render world, and then only cars with fuel will be rendered. There's just some basic updates to the rendering. So they updated the WGPU version that they're using. They made OpenGL backend by default. So apparently Bevy's had this option for a while, but it was opt-in, and now they've decided that it's the default. If you don't specify something else, it'll use OpenGL. They've also exposed non-uniform index support, which is another shader thing. I believe it refers to these numbers here where it's like 0, 1, 2, 3. So this is just you can bindlessly use them. It says that they don't use it yet internally, but it's there for anyone else who wants to make rendering plugins. It's one of those things. I have no idea what this is. I'm sure people that use it will love it, but to me, it's beyond the scope of anything I'm going to use anytime soon. The gamepad API has been improved. This relates to the fact that in in-game inputs, you used to get a raw event, and the raw event can tell you whether a controller was plugged in or already plugged in, what buttons been pushed, what axes have been moved. And if you were, say, looking for controller plug-in and unplug events, you would have to basically skip 99% of all events, because they would be axis moves. And sorry if you can hear anything in the background, it's doing my head in. But so you'd have to filter out all the other things that weren't controller events. But Bevy has now decided to split this into 3 separate event types: controller events, controller axes, and buttons. All get their own event now, allowing you to be more specific with your event readers about which events you actually have to deal with. They've added input method editor support. So this refers to the fact that in certain languages you have accent keys, and in order to apply those accent keys, you hit what's called a dead key. Oh god, I'm having so many interruptions here. Anyway, as I was saying, in some languages they have accents, and in order to accommodate these accents, they have what's called dead keys. And the dead key is a key that when you press has no impact directly, but instead will apply an appropriate accent the next time you press a key. As you can see down here, they're showing examples in different languages, like French is a language that does it. So when they type it out, it doesn't have the accent mark. But then they can, apparently they're using Chinese dead keys, which, obviously you type the whole word and then the symbols appear. And basically, it's enabled basically foreign languages to be used with Bevy, so you can actually read these inputs. Here's an example. So they basically do the accent key and then press E, and it types out. For those that are interested in the history, dead keys refer to the fact that when they had these on typewriters, the dead key wouldn't progress the cradle or carriage, and so it basically was a key that didn't do anything. It just stamped the accent, and then you would stamp the key, and that would progress the cradle. So that's where that terminology comes from, if you're particularly interested. So Bevy reflect paths now enable enums and tuples. So basically you can now do .1 or .0 to get access inside a tuple, and it functions the same as it would on anything else. Interestingly, I don't know how it manages to get into data, because data's an enum, so .1 wouldn't that cause an issue? I guess because it knows what type of data it is? I don't know. I'm not sure how, but it obviously does some complex pathing. You can also pre-pass your paths in order to make them faster, since passing strings is quite slow. If you know, say you're going to be passing the user's input every frame, you can simply pre-pass it, or I guess not user input. If you're passing something every frame, but you know that it's not likely to change, you can pre-pass it and then just pass that every time. There's also the now reflect from reflect functionality. And this allows you to convert a type from its dynamic type that reflect will give you when you clone reflect, that kind of thing, into an actual hard type. And so Bevy now basically implements this as a standard functionality. So in this example, you can see here, you have my struct, but if you then turn that into reflect and reflect clone it, it will give you a dynamic tuple struct, which you would then need to, like, it is no longer the underlying type, as it says. This is not an instance of your struct. So you would then have to use the type registry to get your reflect from reflect, and then you can use reflect from reflect to cast it back down into the solid type that you actually want. This is one of those, in your specific use case kind of thing, you will love it, but otherwise you probably won't notice any of this. But they did improve the speed of reflect and a bunch of other things, like adding more functionality to lists and maps. They also changed certain things in how reflecting components works. So they now take in an entity reference rather than needing both the world and an entity, which just apparently makes them more flexible and usable in certain scenarios. So that's nice. They also just made like serialization or deserialization better because it doesn't clone strings as unnecessarily. Okay, so they updated Taffy, which Taffy is the UI library that Bevy uses in order to get its Flexbox implementation. From, obviously, I think they were using version 0.1, going to version 0.2 significantly improves nesting. So it made the example 8% faster, and they reckon it'll make an even bigger impact on more nested, like the more deeply nested your application is. They also, because obviously they went to 0.3, which adds some like UI tweaks and adds a grid layout, which they haven't yet implemented, but will hopefully come out in 0.11, and you'll see at the end when I talk about the editor, this will be huge for the editors having this new functionality. So another thing they've added is relative cursor position to improve the UI. And the way that this works is it will tell you like where the cursor is relative to that piece of UI. So none if the cursor is not over the UI, 0, 0 if the cursor is in the top left corner of the UI, and 1, 1 if the cursor is in the bottom right. This will allow, so for example, if you wanted to have like a picture of a UI as opposed to an actual UI constructed at runtime by Bevy using entities, you could then use the relative position of the mouse over that image to work out what they're clicking on or where they are. They've also created constant UI bundles. So this allows you to use default in a constant setting, whereas by design, Rust, they haven't said it's not yet. So in Rust, you can't call default in a constant setting because it is a runtime only function, which means that basically all they've done is made a default, like exactly the same thing as default, copy, but that's constantly a const construction that you can then use to initialize your other const constructions. Oh God, thunder! That's great. Another thing I need to interrupt this video. God, I love how this video has taken me like 5 hours to make. Okay, anyway. Hopefully you guys love me going through this stuff so that you don't have to necessarily read it all yourself, even though at this point it probably be faster. Iterating through world entities has changed from giving you a direct reference to from giving you a reference to the entity, or the entity ID, to giving you a reference to the entity. So before, you would have to go through getting each entity, then go get the entity out of the world, and then get the component out of the entity. Now, iterating through all the entities in the world will just return a reference to the entity. No need to then request that specific entity from the world. This is just an optimization by the fact that you really don't need to do that double step. But it does point out here that it is still faster to use a query if you know the exact components. This is more about enabling things like scripting and when you're using like a lot of reflect to interact with the world. So they have also added LCH color space, which is a luminance chroma hue, and this is supposedly got 50% more colors accessible than sRGB, which I guess I think it's to do with the fidelity. Like sRGB can generate any of the colors, but this would allow you to, get sort of in between colors because of just the way that the numbers are calculated. But anyway, luminance is sort of how bright the color is. Hue is how far around the color wheel it is. And I don't know what chroma is, but it obviously changes some property of the color in terms of... But with these three values, you can generate any color that you'd want. They optimized color hex by making it constant, and so it's like 3 times faster to use the hex interpretation for generating colors from hex strings. They split up the core plugins. I'm not entirely sure if they're saying they got rid of core plugins entirely or whether they just yanked this functionality out because it's distinct enough to have its own plugins. But they made 3 new plugins, the task pool plugin, the type registry plugin, and the frame count plugin. These used to be in the core plugin, and they're basically saying that the core plugin was a bit of like whatever they couldn't put anywhere else. So I think they're trying to dissolve it into more named appropriately plugins. They've made entity commands, which is very similar to the section I covered earlier about the like delayed buffering of world access, where entity commands are specifically applied to an entity, but they're just sort of commands. And so what Bevy is talking about here in their implementation is in the old version, 0.9, you would be able to make a command that would take an entity as a field and then would apply the command and to that entity, and you would do the logic yourself. But you would need to specify, like you'd need to keep track of the ID and then provide the ID of that entity to run your command. Now you have a different trait, which is called entity command, which will give you the entity that this command was applied to when the command is run, meaning that your command no longer needs to track this, which means that similar to how you can call like .insert to add components to an entity. Now, when you spawn an entity, you can be like .add my command, and that command could do all sorts of things, such as initialize basic values, set up some kind of, insert additional components that, so instead of having a bundle, you can be like add my command, and then it'll look at the components that are already there and work out what components need to be added in order to complete the bundle, that kind of thing. So lots of nice functionality. These are some new examples that Bevy's added, so like perfect pixels, and what I like the most, so I want to comment on the absolutely adorable pixel art Bevy logo. But anyway, so onto the UI layout example. This shows all the different ways that the Flexbox works in terms of like with a specific alignment and a specific justification content. It shows you how that will end up filling inside the Flexbox, which is just amazing. They've added some new CI implementations, and this is just about like making sure that things don't break when you like change and update things. So yeah, it's just nice improvements, I guess. So this is the first release that has subject matter experts, which is that a few months ago, Bevy put up a post on their page. If you want to go to bevy.org and go to their news. They did a post talking about how they're changing the structure from being like cart, the moderators, and everyone else into being like cart, the moderators, and subject matter people, and then everyone else, sort of like on like a different sort of thing, which means that subject matter experts are people that have contributed lots to Bevy and have been deemed to be like an expert in a particular area, so rendering, ECS, animation, that kind of thing. So the way it works is, I believe at the moment, if 2 subject matter professionals or experts agree on a commit, they can basically pass it and push it through if it's their subject. Like, so if it's a rendering thing and 2 experts in rendering agree, then it gets pushed through without Cart needing to agree and pass it himself. This obviously increases the speed at which Bevy can implement new features, and just also the scope of new features, since Cart no longer needs to actually have an understanding of things that he wants to go in and like to be implemented. He doesn't have to go and make sure it's all done correctly, and this because subject matter professionals are like they know what they're doing. Cart still holds veto rights, but basically, as long as it's not something that he thinks is taking Bevy in the wrong direction, things should be added a lot quicker and a lot more implemented. One thing I do want to add as a comment to this is this update was absolutely massive. and the subject matter experts only came in like the last 2 months or last month of development. So imagine how big the next one's going to be when these people have had their ability to push things much faster from the beginning. This will hopefully mean that Bevys updates are even bigger and grander things in the future, though this may not necessarily be the case, because it could also just be that a lot of these updates have been on the back burner, and having these experts come in very quickly, they could push a lot of things that have, may have been built for 2 or 3 updates and just not had time to be moved, finally got pushed in. But hopefully this means that future updates will also be this big. Okay, so we're moving on to the final section. What's next? So hopefully this video will be done and you've all been enjoying it. So the next thing is the assets system evolution. So basically Bevy is going to allow you to pre-process assets and do things with that. I'm not entirely sure how this actually impacts, because I would have thought with the custom loaders, pre-processing was sort of already a thing you could do. But I have a feeling this has something to do with allowing you to do certain things like making sprite sheets accessible as individual sprites, because at the moment in Bevy, you can use sprite sheets as individual sprites, but you have to have custom, like, it is getting a sprite sheet and it knows how to extract the sprites for its particular render. You can't give something that takes individual sprites a sprite sheet sprite. They're still distinctly separate things. So hopefully this pre-processing will allow for Bevy's assets to treat images inside of sprite sheets, but I'm not entirely sure with that. The thing I'm most excited for is the Bevy editor, as I mentioned earlier. It's going to be great having the editor. This will also, I presume, bolster Bevy's UI library quite a lot, because as they add things to the editor, they will also become things that you can use in your game, since the intention, from what I understand, is to build the editor using Bevy. So that means it's EGUI tucked on top, like the current editors that are available. Instead, it'll be like this editor is built using Bevy. Temporal anti-aliasing, which I believe was supposed to come out in this update, but got pushed back because of restrictions or some kind of like blocking thing, and they just, last thing on the list, so it got dropped. But this is the idea that whereas multi-sampling anti-aliasing will try, take a few samples and work out how to make the edge. Temporal will use the previous frame to work out how to smooth edges. Screen space ambient occlusion is the idea that you sort of can light things from the perspective as if the camera was projecting a bit of light, in order to allow for dark spots to be visible without having weird interruptions and whatnot. So that'll be interesting to see, but for most people won't be that thing. Automatic render batching and instancing. So this, just hearing shit in the background. I hope nobody else can hear it coming through. But so this will cut down on draw calls by automatically instancing meshes that are the same mesh. So instead of making multiple draw calls, if lots of instances the same mesh, it will reduce that, or it will batch geometry together so that you render one mesh instead of having to render lots of little meshes. One-shot systems. These are sort of systems that you can run and they will do their thing, and it says that it's going to do a callback sort of component style. So I guess the idea would be that you can run a system and return the result in a component that you can then use in a different system, so it can ping off one shots that don't clog down the scheduler with runtime checks. It's no, this system decides now's my chance to ping off this system. It will roll one once and that's it. And it might ping it off every few frames, but you don't have to check every frame whether it should run. A different system decides that. Better plugins is about customizing plugins so that third-party plugins can have better architecture about communicating with each other, and eliminating the you've got to initialize them in a particular order so that the dependencies are all incorrect, and also you can define dependencies between different plugins to define how they should initialize. I suspect this will be done with a late initialization, in that when you build your application, it kind of queues it up, and then when you call run, it actually builds the application. since that will allow it to sort of build a map of what needs to be initialized in what order, because it already knows every plugin when it goes to build. They intend to remove all non-send data out of the world. So apparently storing non-thread safe data in something that's designed to be thread safe is quite a headache. So they're planning to remove all that and put it in the app level as opposed to the world level. And this is apparently a major blocker in first-class mutable world access design. So hopefully that will mean that once that's out, Bevy can innovate its world design much faster and hopefully implement a lot more improvements. Time step window and input events is about having sort of a timestamp on events like your keyboard presses so that you can sort of know which order the keys were pressed. At the moment, I believe Bevy just sends it as in like you press these keys on the click of the side of the frame, these keys were pressed, whereas this will have like a time step so that if your frames take too long, you actually still know which order these keys were pressed in. Opt-out change detection will allow for like small components and stuff not to have change detection, since this will it bloats their size, bogs them down on very small components that you may not use the change detection. So it'll be nice to be able to say like don't do change detection on these particular things. And also, this is I mentioned earlier when I was talking about the animations, is the comprehensive animation composition should support non-traditional animation compositions, i.e. Arbitrary weight blending of animations, which is, I believe, when you use like the legs of one and the top half of another. But I'm not entirely sure because, again, animation is not my field. So if you want to see what's happening in the next release of Bevy, there's a link to the milestones at the bottom of the post. And I finally made it to the end. So I hope you've all enjoyed the video. I took way too long making this, and I absolutely hate it. But I do like, comment, subscribe. In the future, I will hopefully do a 0.9 to 0.10 migration guide. I also intend at some point to do a live stream. I just hear beeping in the background. I intend to do a live stream porting the my platformer in Bevy from 0.9 to 0.10. And so if you want to try and catch that, if you miss that, there will also be a video condensing that live stream when it happens into a 10-minute video explaining how you go about porting a game from one version to another of Bevy. And I hope you'll like, comment, subscribe, and I will see you in the next one. And thank you for sticking around for an hour and 20 minutes. Oh my god.